Antenna and wave propagation using HFSS software. You can check out the first video by checking out the link given in the description box. In that video we have discussed about the fundamentals of antenna and some of its properties like reciprocity, radiation pattern and input impedance. In this video we continue with the other properties of the antenna. So let's get started. The first property which we are discussing now is the return loss of the antenna. It is also known as the reflection coefficient or S11. It is in fact a very important parameter of the antenna, and we have devices which are used to measure this particular parameter. These devices, they are known as vector network analyzer. Basically, return loss ratio expresses the mismatch in the performance of the antenna. Mathematically speaking, it is a logarithmic ratio which is measured in decibels, and it compares the power reflected by the antenna to the power which is being fed into the antenna from the transmission line. Any reflected power from the antenna will be at least some decibels below the input power. This drop in the decibels is basically the return loss ratio, and it will increase considerably if the antenna is mismatched. Now, even though return loss ratio is indicative of the mismatch between the antenna and its source, but still it is not the accurate measure of this mismatch. This mismatch measurement can be accomplished by using another parameter which is known as SWR or standing wave ratio. A mismatched antenna reflects some of the incident power back to the transmitter. Now, since this reflected wave is traveling in the opposite direction as the incident wave, so inside the transmitting cable some points are created, and at these points the two waves will be in phase with each other. The ratio of the voltage at these 2 points is known as SWR, or sometimes it is also called VSWR, that is the short form for voltage standing wave ratio. The relation between SWR and return loss is given by the formula shown in the figure. The next topic which we are discussing is the bandwidth of the antenna. Now, as said earlier, if SWR value is high, then it denotes that the antenna is not suitable for the source. Again, if we change the frequency, the location of the points where we are measuring the SWR value will also change, and this might change the value of the SWR as well. So the frequency range for which this SWR value is at least less than 2 will be known as the bandwidth of the antenna. Now let us talk about the directivity and gain of the antenna. Both these terms are closely related to each other. Directivity is the ability of an antenna to focus energy in a particular direction during transmission, or we can say that it is the ability to receive energy better from a particular direction while receiving. An antenna that radiates equally in all directions would have directivity less than 1 dB, because we can't represent the directivity with 0 decibels. Gain is similar to directivity, but it is a dimensionless ratio. It is always measured in reference to a standard antenna. This standard antenna can be an isotropic antenna or the resonant half wave dipole antenna. Let us consider the isotropic antenna for the instant. So basically the isotropic antenna is an antenna which radiates equally well in all directions. Of course, it is a theoretical antenna only, because any real antenna will radiate more energy in some direction as compared to the other directions. Now, since antennas cannot create energy, so the total power radiated in this real antenna will be the same as an isotropic antenna. So in other directions it will be radiating less energy. The gain of an antenna in a given direction will be the amount of energy radiated in that particular direction compared to the energy that an isotropic antenna would have radiated in the same direction when both of them are being driven with the same input power. So we'll wrap up this video with these topics. In the next video we'll discuss about some other properties of the antenna, and also we will start with the HFSS software demo.